Hello everyone and welcome to this video on creating computer-aided manufacturing programs or CAM programs in Autodesk Fusion 360. In this video we're going to look at creating a CAM program for the example component that you can see on screen now. If you would like to follow along with this example, you can find the F3D file in the video description below. Okay, so when we first open up this file, we will be dropped into the design workspace by default within Fusion 360. This is the workspace in which we create 3D geometry and we model our components. We would then want to create a manufacture program for these components, then we need to go into the manufacture workspace. So we do that by going to the top left, clicking on the design button and going down to manufacture. Now for this first example, we're going to keep things relatively simple. We're not going to include a fixture and we're not going to do any probing operations. So the first thing we need to do for any CAM program is to create a setup. So we do this in the setup group at the top, and we create a new setup. And in the setup we need to give Fusion 360 some key information. So the first thing is, what sort of operation are we doing? So for this component we will be doing a milling operation. We won't be doing a turning or a cutting operation or anything like that. The next most crucial thing is to make sure that we have the orientation of the CAM program set correctly. So at present the orientation is defaulted to the model orientation. Now you can see for this particular model we've modeled our component with a y-axis facing upwards. This is not ideal because the convention for CAM programs and CNC machines is that the vertical direction is Z. So if we were to proceed with the component in this direction, essentially we would be telling Fusion that the component is mounted like this in our vertical milling machine, and that the tool approaches from the Z direction. This would mean that we can't get any access to the pockets on the side, and obviously this wouldn't be a good approach for milling this particular component. So we need to change that. So I'm going to pick the top option, select Z axis plane and X axis, and then it's going to ask me for a geometric reference for the Z axis. So I'm just going to pick this top surface here, and I can see my Z axis is now normal to that top surface. And then it's also going to ask me for an x-axis, so I'm going to make the x-axis along this edge here. Now you will need to look at your particular milling machine for the convention on which directions x and y are, and hopefully set these accordingly. Next thing I need to do is I need to set where my origin position is. So the default is to set this to a stock box point, which is correct, and I can pick the box point here. So if I press this button on the side, I get a number of box points that I can pick from. It's currently in the top face, or the center of the top face. I could put it right on one corner or right on one edge, for example. Now where you have your work coordinate system placed on your stock is or depends on how you are setting this piece of stock up within your milling machine. So if you're going to use some sort of edge finding tool, you may well want to set your work coordinate system on a corner, and then you can find two edges to set your 0, 0 position. For the remainder of the examples that I'm going to present here, we're going to be using a probing operation to set the work coordinate system location. So I want my work coordinate system to be in the top face, the center of the top face, as it is here. The next option is what we are actually milling. So if I pick the body icon or the body arrow here, it will show me what Fusion 360 understands it to be milling at this particular moment, and this is correct, so we don't need to do anything here. If we did have other items within this model or assembly and we wanted to set a fixture, we would do this down at the bottom here. So I'm finished with this tab, so I can go across to the stock tab. Now here I set the size of the stock that I'm going to use to make my component. Now at the minute this is set to a relative size box, and what this means is that Fusion has created a piece of stock material which has certain offsets from the bounding box of my model. So at the minute I've got 1 millimeter of stock on the sides and 1 millimeter of stock on the top. This is absolutely fine, so I'm going to press OK on this. If you did have, or if you knew you were making your component from a particular size of stock, you would want to set this to a fixed size box, and you would want to enter the dimensions of that stock manually and make sure you got the offsets correct. But for the purposes of this example, we don't need to do that. As we're trying to keep this example relatively simple, we'll also not be doing any post-processing, so we don't need to worry about that tab either. So if I press the OK button now, that will create my setup, and that will allow me to create toolpaths and machining operations. Now, as I've mentioned before, we're gonna take a general approach to how, or the order in which we create toolpaths within our CAM programs. It's very useful to get used to the order in which we do, you create these toolpaths before you start changing their order. Once you've got enough experience, you'll be able to say, or you'll be able to determine the order of these toolpaths yourself. So there is no hard and fast rule to the order of these toolpaths, but I would suggest sticking with the default that I suggest here just for now. So the first toolpath that we're going to create is a face milling operation. A face milling operation is going to remove any excess stock material on the top of the component, and it's going to leave us hopefully with a nice finish along all of this top surface of our component. To do a face milling operation, I go to the 2D group and I go to face. Now with all of these, the toolpath dialog boxes, I'm going to be working top to bottom, left to right across the tabs. The first thing I need to tell Fusion 360 is what tool I am using. So if I go to tool and I go to select, for the purposes of all of these examples, I'm going to be using the tutorial metric library. If you can't see this, it is in the samples folder and it is right at the bottom. The reason I'm using this library is it's got a good variety of tools, but it also has not got too many tools. So what you'll often find in an industrial setting is that you have access to a limited number of tools and you need to design your components to be able to use those tools. If you are constantly designing components which need new tooling to be ordered, you're not going to be very popular in the workshop, and your components might not actually get made. So we're going to try and stick to using just the tools within this particular library. Now there's only one face mill in this particular library, which is a 50mm face mill, so I'm going to select that. Now as we select the tool, we'll see that our feeds and speeds change automatically. This is because as well as storing information about tool geometry within the library, Fusion 360 also stores metadata relating to the feeds and speeds of that particular tool. So because they've been set, we're going to leave those as default for now. As I've mentioned previously, if we're actually going to post this out and use this on a machine, you need to double check your feeds and speeds against manufacturer or tool manufacturer guidance for every single tool that you use before it goes anywhere near a machine. So we're done with that tab and we can move across to the geometry tab. Now for most toolpaths, we would need to pick some geometry here. The face milling toolpath is the exception in that it doesn't require us to pick any geometry in order to create a valid toolpath. So I can just leave that as default. I can look at the heights. So the main two heights that I need to look at are the top height and the bottom height. So the top height is where our toolpath is going to start milling and removing material, and the bottom height is where it's going to stop milling and removing material. So it's going to start milling from the top of the stock, and it is going to stop milling at the top of the model, which is perfectly fine for this particular operation. In the passes tab, I have some additional options. So if I want to machine at multiple depths, if I want to leave some stock on, and if I want to change the direction of my face milling operation, I can do that here. I don't need to set any options here, and I don't need to set any options in the linking tab either. So I can press OK at that point, and that will generate the toolpath for my face milling operation. Now it's always a good idea to simulate our toolpaths to make sure that what we are manufacturing matches up with our intended geometry. So we can do this in the actions group, and we go to simulate. Now by default, the stock button here will be turned off, so you want to enable visualization of stock, and the default colorization will be set to operation. This means that as we simulate, the stock will turn a different color relating to which operation has been performed. By far the most useful colorization option is comparison. This means that that Fusion 360 will change the live preview to show us areas where we've got too much material, which is shown in blue, where we've milled to the correct geometry, which is shown in green, and if we remove too much material, it will show that in red. So this is a really good way to check that what we are making is actually correct. So if I finish that simulation there, I can see that the face milling operation has removed all of that material on the top of my component. At the minute, the face milling operation is going across my component here. If I wanted to change that, I can change that by right-clicking on the toolpath and going to Edit, going to Passes, and where it says Pass Direction, if I change this to 90 degrees and press OK, we'll see that now, instead of going across the component, we'll be going along the component. So if I just simulate that again quickly. Okay, so now I can move on to the rest of my operations. So the next toolpath that I'm going to create is a 2D adaptive clearing toolpath. The 2D adaptive clearing is a really nice toolpath, so it requires the user to specify relatively little information, and it does a good job of removing the maximum amount of material while minimizing forces on the cutter. So if I go to 2D adaptive clearing, and again I'm going to follow the same process, I'm going to select a tool. This time I'm going to opt for a 10mm bullnose cutter. The reason that I'm doing that is because the radii in the corner of these pockets here is 10mm, so I've picked a cutter with a radius that matches that. And the reason that I've gone with a bull nose rather than an end mill is that the rounded corner on the end of the bull nose will actually reduce wear on the tool, and I'm not too concerned with creating the exact component geometry with this tool operation, so it doesn't really matter that this has not got a square corner. The next tab on geometry, I'm just going to pick the outlines of all of my pockets. On the heights tab, I need to set where I'm going to start machining and stop machining. So I'm going to start from the top of the model. I don't need to start milling at the top of the stock because I've already removed that top bit of stock in my facing operation. The bottom height, where I'm going to stop milling, I want to stop milling at the bottom of these pockets. Now there isn't a default selection here, so I'm going to go to the selection option, and I'm just going to click the bottom of the pocket, and that will set my bottom height accordingly. I'm not going to change any of the options in passes, so I am going to leave some stock because this is a roughing operation, and I don't need any of the linking options either, so I can press OK. Now we'll just simulate that whole setup quickly, and I'll just increase the speed. So you can see for each pocket the tool is spiraling in and then working its way outwards to remove all the bulk of the material within those pockets. We still have 0.5mm of stock on the sides and on the bottom. So the next operation that I'm going to do is a 2D contour. So if I go to 2D contour here, and what I want to do now is I want to clean up the inside surfaces of these pockets. So here I'm going to select a 10mm flat end mill. Again, I'm going to pick all of the pocket edges. I'm going to double check my heights, so I want to start milling at the top of the model and I want to stop milling at the bottom of the pocket. And this time I do want to set some options on my passes tab, so I don't want the tool to just go straight into the pocket and go all the way around the edge. I want it to do 2 passes at 2 different heights, so I'm going to enable my multiple depths tab, and I know that these pockets are 20mm deep, so I'm going to set my maximum step down to 10, so that means it's going to do 1 pass at halfway down and 1 pass at the full way down. I'm happy with that, so I can press OK. And then if we just simulate the whole setup once more, we can see the face milling operation, we can see the 2D adaptive clearing. We can see that contour operation has cleared up the outside. What it hasn't done, however, is remove the excess material in the bottom of these pockets. So I'm just going to add another 2D toolpath in order to do that. And for this, I'm going to use a 2D pocket operation. Again, I'm going to use a 10mm flat end mill. Again, I'm going to pick the pocket selections. Again, I'm going to set the heights, so on the top of the model, and I want the bottom of the pocket. And I'm just going to press OK. Now I know this is not going to generate the correct toolpath, but let's simulate everything that it's doing here. So I can see the adaptive, and I can see the 2D pocket operation is moving lots, but it's not actually doing anything. So I think what's happening here is we've left the option enabled, which will leave stock on this particular toolpath. And we've also set the heights wrong, so we can see for the 2D pocket, it's starting right at the top of the model, and it's spiraling all the way down here in fresh air before it touches any material. So what we need to do is we just need to go back into that 2D pocket operation, and we need to edit that. So on the passes tab, I don't want to leave any stock, so I'm going to untick that. And on the heights tab, I don't actually need to start at the top of the model. I do need to go down to the bottom of the pocket. So all I'm going to do is I'm going to use the offset option on the top height to move the top height right down towards the bottom of the pocket. It only really needs to be a few millimeters above that. If I press OK there, I can see now that I'm doing very little spiraling, and hopefully now when I simulate the entire setup, I should have the correct pocket geometry. Excellent. So that's the geometry that I wanted. So the last two things I need to do now are to clean up the outside of the component and to drill the holes. So let's do the outside of the component first. Because there is very little material on the outside, I'm going to do this with a 2D contour operation. So I'm going to do this in a similar way to what I did with the pockets on the inside. So I pick the contour. Sorry, first of all, I need to make sure I've got the tool specified correctly. Ideally, when we're creating CAM programs, we should be using the largest possible tool. Now, there is a sort of a trade-off here, because what I could do is I could go into select, I could go back to my library, and I could pick something like a 16mm flat end mill, which would be a good selection for this particular operation. The issue here is that I'm now using lots of tools within my program. So as well as using the largest possible tool, I should be making an effort to minimize the total number of tools used within my setup. So I'm going to leave this at 16mm here, but just be aware that you should be trying to minimize the total number of tools used for your particular setup. The geometry I've already picked. The heights, I want to start at the top of the model, and I want to stop at the bottom of the model. And then on passes, I want to do multiple depths here again. I know the component is 30mm tall, so I'm going to set my maximum step down to 15mm, so I will do 2 nice passes around the outside of the component. So I'm going to press OK there, and let's see what that's done. Excellent. I'm happy with that geometry that's created. So the last thing I need to do is a drilling operation. So I go to the drill tool. Again, I need to pick my tool. I know these are 5mm holes. So if I go to tutorial metric and I find a 5mm drill and press OK, I go across to my geometry tab. The hole mode will allow me to pick various different bits of geometry in order to select where my holes are. I'm happy that I want to select the faces, so I'm just going to pick the inside face of that hole, and Fusion will recognize it. If I then hit the select same diameter checkbox, it will pick all of the holes in my model that are the same diameter. I'm happy with that, so I can press OK. And hopefully now, when I simulate my entire setup, I will have a finished component which looks green. So I've got the face milling operation, the 2D adaptive to remove the bulk of the material in the pockets. Got a 2D contour to clean up the inside of the pockets. I've got a 2D pocket operation to clean up these bottom faces here. I've got another 2D contour to remove the material from the outside of my component, and finally a drilling operation to drill my 5mm holes. To just get a clearer look at that, I can untick the toolpath checkbox to remove all the toolpaths. I can also hide my models, so all I have is the preview. If I look around that component, that looks all green. So I'm happy with that program, and I'll consider that finished. Now, there's certainly a lot of optimization that I could do to this program. I could have also picked a different toolpath to create different geometries as well. What I would advise is that you practice creating some of these toolpaths first, and then perhaps experiment with some of the other options you have in the 2D and the 3D groups to create different geometries. Okay, thank you very much for your attention, and I will see you in the next video.